Hi May, I just said I'd make this quick little video. I'm going to apologise about the videoing skills in advance. If I give up the teaching career, I definitely don't think I'll make it as a vlogger, but hopefully it won't be too shaky anyway. I'll try and keep it as still as I can. So I'm just going to fly through this question that I did in class with girls the last day. Just to explain here, this is the 2016 question 1 calculation. Since 2016, really you have to use the first principle method. You were able to use the quick equation up until then. I'm shaking the camera already, but since then, first principles is kind of the way we need to go with it. Now I don't know, they might throw a different question up for next year, but I want to go through this using first principles because you can always use first principles, but it might take a little bit longer, whereas then there'll be occasions that you're not going to be able to use the equation. So again, here your first indication that we're not going to be able to straight away use our equation here, or our formula rather I should be saying, is because we are given the mass of one of our reactants. So because we've been given the mass here and we haven't been given molarity straight away, I'm going to have to use first principles. Okay, so I want to go through this with you first, so I'll pause as we do each part and reset the camera again. So to determine the concentration of ethanoic acid in a sample of vinegar, 25 centimeters cubed of vinegar were diluted to 250 centimeters cubed. And then the diluted vinegar was titrated with a previously standardized solution which contained 1.2 grams of sodium hydroxide in 500 centimeters cubed of solution. On average, 18.75 centimeters cubed of the dilute vinegar were required to neutralize 25 centimeters cubed of the solution. And then it gives you the balanced equation in the question as well. Okay, now the first part of this, so part C, A and B were theory questions, part C is the first part of the calculation. So part C, part 1, calculate the moles of sodium hydroxide in each 25 centimeter cubed portion. Before I look at these, the one thing that I'm going to say just as a little side note here, just to take account of, if the titration on vinegar comes up, the special part of this is the dilution. Okay, so straight away whenever you see the vinegar titration, the first thing I want you to do is work out, if it isn't said explicitly, I want you to work out the dilution factor. Okay, and have that just as a little side note in the corner because you will end up using that at some stage. Okay, so how do I work out the dilution factor? First of all, why is it diluted? The vinegar is diluted because if we use the vinegar straight out of the bottle, the concentration of the ethanoic acid is going to be very high. And as a result, it would take an awful lot of your sodium hydroxide to neutralize it. And we don't want to be wasting all of that sodium hydroxide. So a simple way to avoid that problem is if we dilute it down by an accurate figure. So if we dilute it down accurately, all we have to do is multiply out our final result at the end to be able to incorporate then that dilution factor and find the actual concentration of the ethanoic acid. I hope that makes sense. So that's why we dilute it. It's to not waste any of our NaOH because it would take so much NaOH to neutralize it. Okay, so our dilution factor, how do I find out the dilution factor? So to determine the concentration of ethanoic acid in a sample of vinegar, 25 centimeters cubed of vinegar were diluted to 250 centimeters cubed. So I took 25 centimeters cubed from the bottle of vinegar and diluted that using our famous distilled water to 250 centimeters cubed. What did I do to 25 centimeters cubed to get to 250? I multiplied by 10. Okay, so that means I have a dilution factor of 10. So when you come to the last part of your calculations, when it says to bring it back to the original vinegar or original ethanoic acid, you know that you're going to have to multiply your answer by 10 because that was your dilution factor. Okay, so I hope that part makes sense. Now, to get into this, so calculate the moles of sodium hydroxide in each 25 centimeter cubed portion. So for first principles, you always want to bring this back to molarity, okay? If you bring it to molarity, we can work with moles and we can also work with different volumes because we're going to have our baseline volume of 1,000 centimeters cubed or a litre that we'll be able to manipulate easily depending on what the question is asking, okay? So that's always our first port of call. Now you need to remember some things here as we go through it, like how do we find the number of moles if we're given a mass, etc, etc. So we're going to go through that. So the first thing you do with these questions is write down what you need to know. Now I've written out the question here, so I'm just going to highlight what the relevant part. So calculate the moles of sodium hydroxide, so we need to recognise it's sodium hydroxide that we're looking for here, of each 25 centimeter cubed portion. Okay, so it's 25 centimeter cubed portion. Then we go back and we look at the question. Where does sodium hydroxide come up? We have 1.2 grams of sodium hydroxide in a 500 centimeter cubed portion. So this is a known. I know this information. It's coming from the question. I know that there is 1.2 grams of this in 500 centimeters cubed. Okay, that is just after coming straight from my question. Now, that's not what I want. I want the number of moles and I want it in 25 centimeters cubed. So we're going to bring this to molarity first, okay? So to bring this to molarity, what we're going to have to do is, first of all, we need to bring this up to 1,000 centimeters cubed, and then we need to find the number of moles. So to bring this to 1,000 centimeters cubed, I'm going to have to multiply by 2. 1,000 centimeters cubed. What I do to this side, I must do to the other side to make sure that my ratio remains the same. So I also need to multiply this by 2. Okay, so now I can see that I have 2.4 grams per 100 centimeters cubed. Okay, so that's the first part. Now I need to recognize that, but I need moles. So I'm going to find molarity first. How do you find the number of moles if you've been given the mass? You have to divide by the molecular mass. Okay, so you have your NaOH, so you find out what the molecular mass of this is, and when you add it all together, it's actually 40. So the MR is 40. You can check that using your periodic table, or you can trust me, one or the other. Okay, so we're going to divide this by 40. So when you divide your 2.4 by 40, that is going to leave us with 0.06 moles. Whoops, I'm trying to look at this through the camera. Making a mess. 0.06 moles per litre, or moles per 100 centimeters cubed. Okay, so now I'm going back to the question. I have moles, but I have it in a litre or 1,000 centimeters cubed. Okay, I need it in 25 centimeters cubed. So what I have to do then is I get my 0.06 divided by 1,000, and I'm going to multiply that by 25. Okay, so 0.06, that's what we're after calculating here. I divide that by 1,000. The reason I do that is that'll give me the mole in 1 centimeter cubed. When I multiply that then by 25, it will give me the number of moles in 25 centimeters cubed. When you do that out, it gives you 0.0015. So your final answer to this part then would be that there are 0.0015 moles per 25 centimeters cubed. So I hope that makes sense. Sorry that is all over the place and it took me 10 minutes to get through.